Alright, so in this video, what I'm going to try to do is I'm going to do a related rate problem. So what we have here is we have this problem here. We have here we have that and is traveling north. So we have that and is traveling north. Let's say 2 miles per hour. Okay, so she's going to be traveling at 2 miles per hour. And then we have that Paul is traveling west. Paul here is going to be traveling west. Let's say at 1 mile per hour. Okay, so 1 mile per hour. And they started at the same point. They both of them started at this point here at the same time. So the question is, the problem is that we want to address is problem. How far or what rate is the distance between them changing at exactly 2 hours? So at what rate? At what? Okay. At what rate is distance between them right? Changing at 2 hours or after 2 hours. Okay, so we are trying to find the rate of change of this distance, the direct distance between them at 2 hours. Okay, so this is the distance, whose rate of change we want to find at exactly 2 hours. All right, so they began at the same time, one going north, one going west. Okay, so here we have a right triangle, right? So we have a right triangle right here. So immediately this evokes the Pythagorean theorem, which I'm going to write down here. Okay, but first let me actually bring to your attention, I am going to refer to n as a. Okay, so this distance here I am going to refer to as a. So this is going to be a. This is going to be p. And I'm going to call this distance here capital D. Okay, so D. So the Pythagorean theorem tells us, okay, the Pythagorean theorem tells us that the Pythagorean theorem then tells us that let me write the Pythagorean theorem here. It tells us that d squared, this distance here, squared, is equal to a squared plus b squared is equal to a squared plus b squared. So now what we want to know is what happens at exactly 2 hours. So at exactly 2 hours, the distance a, so at 2 hours, okay, a, because n is traveling at 2 miles an hour, is going to be equal to 4, and p at 2 hours, since Paul is traveling at 1 mile per hour, is going to be 2. Okay, so let me actually, this is an important, so I'm going to box this in. This. All right, so we have that situation going. Okay, so because D, A, and P are changing as a function of time, they are all functions of time. I am going to differentiate this expression here, d squared equals to a squared plus p squared, implicitly. And my objective is to find the rate of change of d being this distance here. All right. I want to find the rate of change of d when the distance, or when the time elapsed has been 2 hours. All right, so let me actually differentiate this implicitly. Now, if you don't know how to differentiate implicitly, you have to actually review implicit differentiation, because you need to differentiate this implicitly. So let me actually do implicit differentiation here. So I'm going to take the derivative of this expression here in respect, okay, to time. So I'm going to go, let's see. So this is going to become, let me do this in another color. Okay, let me do this in burgundy. So we have that d squared dt is going to be equal to d dt of a squared plus p squared. Okay, so we have this here. Now, so the derivative of d squared, d is a function of t in respect to time, is going to be equal to 2 times d dt. And this, of course, is going to be equal to the derivative of a squared in respect to time plus the derivative of p squared in respect to time. This, of course, is because differentiation is what they call a linear operator, so it moves past addition, or respects addition. Okay, so let's actually do this. So here we are. So we have then, so this is going to become then 2a dA dt plus 2p dp dt. Now, fortunately, from the stated assumptions here, we know that n is traveling at 2 miles per hour, so this says that dA dt, okay, so we know then that dA dt is equal to 2. Now, we were told also that pole is traveling at 1 mile per hour, so this is that dp dt, or rather we know, is equal to 1. So we have this data here, which is very, very useful, and we will use. Okay? All right, so now what is happening? So what is happening at 2 hours? At 2 hours, A, we said, was going to be equal to 4. So let me actually substitute these values here. Okay, so at 2 hours, we have that A is equal to 4. dA dt, of course, is equal to 2 because n is traveling at 2 miles per hour. So let's actually insert this information in here. So let me actually clean this up a little bit. So we are looking for the rate of change of big D. This is big D here, capital D, sorry. Capital D. Okay, this is capital D here. We're looking for this rate of change in respect to time at 2 hours, when t is equal to 2 hours. So let me actually insert all this data that I have here in these two boxes into this expression here, this equation. All right, so let me begin. So I have 2a, so at 2 hours, okay, so this is going to be equal to 2 times 4 times 2 plus 2 times at 2 hours, this is going to be 2 here, p is going to be 2, and Paul travels at 1 mile per hour. All right? So we have that this over here is equal to 2d dd dt. And now what I'm going to do is, of course, I'm going to divide both of this, both sides by 2d. All right? So let me do that. Okay? So when I divide by 2d over here, obviously this is just going to become 1, so I can erase it from here. I am erasing here. And I am going to have 2d here. Okay? So my objective now is to find d. But you know, I have d, I want to find d at exactly 2 hours. So, well, I know that d is equal to d is given by this expression over here at 2 hours. So I am going to use the Pythagorean Theorem. Okay, so I want to find d. So this implies, what I have done so far implies that d is equal to a squared by the Pythagorean Theorem, rather d squared, I should say. Okay, d squared is equal to a squared plus p squared. Okay, so d squared is equal to a squared. Well, a at 2 hours is going to be equal to 4. So I am going to write 4 squared plus, at 2 hours, p is going to be equal to 2. So I'm going to write 2 squared, right? So this implies really, this implies, so this says that, this is saying that d is equal to the square root of 20, right? 16 plus 4. So we have this information here. So this is saying then that this is equal to, well, let's see. This is going to be equal to 16 plus 4. This is going to be equal to 20 over 2 times the square root of 20, right? So if I simplify, so the distance, the rate of change of the distance, the direct distance between Anne and Paul after 2 hours, or at exactly 2 hours, is equal to this. And so this is miles per hour. So I can simplify this further for aesthetic reasons. So this is just going to become 10 over the square root of 20. And if I rationalize the denominator, this is just going to become 10 times the square root of 20 divided by the square root of, divided by 20 here. So this is really going to be the square root of 20 divided by 2. So this over here, sorry, we're not able to see this here. So this over here is the rate of change of d in miles per hour. So the answer is, okay, my answer is okay, so this is in miles per hour. Okay, so d is changing at this speed, the direct distance. So that is the solution to the problem. Thank you for listening.